Welcome to the statistics learning session. Today, we'll talk about chi-square test for two modalities. It's lecture 15, part 8. Now let's begin. Moving on to coordinates distribution, which differ from discrete distribution in their application of certain tests. Though some those tests also apply to discrete distribution, but they are really tailored. CDF. A random variable is characterized by CDF. That is, FT. This is called CDF, FT, and it is equal to E and indicator of X less or equal to T. That's a FT. By replacing expectation with average, we get empirical CDF. That is, now, now let's suppose we replace this with the, we can replace expectation with empirical CDF. That is, we can sum for discrete distributions, we can sum the individual values and take average of that, and we can treat it as a CDF. But for continuous case, we cannot just keep add for continuous case. It's a bit different. The PMF does not exist for continuous distribution, but CDF do always exist. CDF for a continuous distribution is defined as FT P X or less equal to T. That's a CDF of continuous distribution. While the CDF of discrete distribution is defined as a I is a sum of the this is a contents of the discrete distribution. Now the CDF goes from minus infinity to positive infinity, and it's a probability, so it never takes a value greater than 1. Now I have a question for you. For a symmetric random variable, what is the value of CDF at median? Think about it. It is 0.5. That is, for symmetric distribution, it is around 0. For a symmetric distribution, if the value is 0, if the value is 0, then the median is then CDF is 0.5 at 0. Example of CDF for uniform distribution. For a uniform random variable on interval 0 to 1, CDF is a straight line from origin to 1, 1. Before the left point of the support 0, CDF is 0, and for rightmost point 1, CDF is 1. Let me show you what I mean. What I mean is that now, let's say we have this graph here, and this is a 0, 0, and left of that CDF is 0 here, and for uniform distribution it goes from 0, 0 to 1, 1, and after this is always 1. It doesn't go beyond that. This is a CDF of uniform distribution. and is a uniform distribution and continuous distribution. Now let's go to the, let me show you the CDF of a uniform distribution where it is a curved shape. It is a S shape. That is, it goes slide like this, and it goes, and it's a S shape. This is CDF of a standard normal distribution. So let me quickly summarize what we learned today. We learned that continuous distribution differ from discrete distribution, and CDF is a key concept in understanding them. CDF represents the probability that a random variable is less than or equal to a certain value. Empirical CDF is an estimate based on a sample data. For a continuous random variable, CDF always exists while PMF does not. CDF has specific properties such as being bounded between 0 and 1 and increasing as variable increases. Examples include CDF of a standard normal, S-shape, and uniform distribution, 0, 1, straight line. That's all for today. I'll see you next learning session. Thank you so much.